while this is being prepared, I will talk about the cooperation between brain and intelligent machines. And this is an area of study that progressed over the last several years at an amazing speed. And I would like to tell you a little bit about what has been happening and what we can expect in the future. Though the attempt to create machines that will be intelligent and will be able to think on their own started from the very early days of the pioneers of computer science. I will mention in particular Alan Turing. This is the picture of Alan Turing, because now this year in 2012, all over the world, it's called in computer science the Turing year. He was a fundamental pioneer in the field, and we are celebrating 100 years to his birth. And he was one of while he started many of the theoretical aspects of computer science, together with this, he was an early pioneer of trying to build machines that will rival the human brain. Things started slowly, but the question I want to examine now, without giving a conclusive answer, is: are we now at the dawn of a new age of truly intelligent machines? We already had a number of great successes throughout the recent years. Perhaps the best known one, which really made a splash in 1997, where the computer called Deep Blue, constructed by IBM, managed to beat in international competition for the first time the world champion in chess, Garry Kasparov. The score was 2-1 with 3 draws out of 6 games. So the machine became for the first time the best playing system on our planet, better than the world champion. This was extremely impressive, but at the same time there is something limited about it, because chess is a very specific, focused, narrow domain. And the question is, can machines do something which is closer to the human brain, which be very flexible, creative, learn new things, and so on, which is not what Deep Blue was able to do. So after the years since 1997, I think that the biggest splash, just because of the limitation I mentioned right now, came last year in 2012, when a machine built again by IBM called Watson became the world champion in a game called Jeopardy. And those of you here who come from the States will probably recognize what this is all about. Here in Israel, most people maybe didn't hear about Jeopardy, but it's a very popular television game, basically a quiz, and it's completely open, so almost any question can be asked. The questions are difficult and tricky, and it really takes a subtle mind and a lot of intelligence to be able to play this game well. So IBM decided to build a machine and then to openly put it on the stage, and you can see here 2 human beings and 1 computer. This is connected to a computer. There is no person there, and are competing neck to neck. The question is being read out, and whoever answers first wins points, and so the thing continues. And after 3 days of intense competitions, many questions being asked and answered, the computer won. Watson became the world champion in this open game, and proved that intelligent machines can deal with very open, flexible domains. Let me give you one example of a question that actually happened during this competition. It's written here in Hebrew. In May 1898, Portugal celebrated the 400th anniversary of the arrival of this traveler to India. The answer, I don't know how many of you immediately know the answer. The answer is Vasco da Gama. Watson answered it in a split of a second. And the interesting thing was that there was no explicit mentioning of this fact in Watson's database. There were bits and pieces in various ways. For starters, you have to walk back and understand that it's a 400th birthday, so you should go 400 years earlier and look for events at that age, and so on and so forth. Everything came together very, very quickly and Watson did it immediately and better than humans. Now, this is a game, but you can imagine what this kind of ability can do to real systems. For example, IBM is now applying it to medical diagnosis. And you can think about going to a doctor and just imagine that you know that the doctor has such a system helping him, that anything that was ever written in the field of medicine about a particular disease you might have, it's there. The doctor may not know about it, but the machine will and will make the right predictions and connections and so on. So that's really can be a very, very helpful thing to have in real life. So this is up and coming, but if you think about it, we have already intelligent machines in our daily lives. Google search and other search engines are quite intelligent. Another example, a small example, but a telling one, in the States there is a video renting service called Netflix that rents out videos, and it makes very good recommendation. It guesses what each person is going to like. And this guesses what people like based on a variety of parameters is a complicated issue. Here is showing you a part of the formulas inside of how this Netflix makes it guesses of what people are going to like. So it's a complicated domain. And if you think about it, being able to have models of people and being able to predict what people are going to want and to enjoy is a very interesting capability. Last example, just because it appeared last month, just a few days ago in the New York Times, there was a system which was put to work in the school system in various places in the United States. The newspaper piece was called "The Algorithm Didn't Like My Essay." It's an automated system that reads student essays when they finish high school and grades them instead of human graders. A thing which is close to my own area of investigation is building machine that will be able to see. We all know about cameras that can recognize faces. There is a new camera out there that can recognize pets, for example, and it can shoot a good photograph of your cat or dog. It's really already in existence. There is a technology now in new cars doing driving assistance, can warn about the driver from obstacles, other vehicles, pedestrians, and so on. It's interesting to note this particular one because perhaps the leading company in this domain, serving companies from BMW and Volvo and Honda and many others, is an Israeli company called Mobileye, which was developed by Amnon Shashua, professor at the Hebrew University. It's a leading company, the leading company in this domain, and this is just the start. People are now experimenting with driverless cars. There is a car there which does not have a driver and can drive along the road, and people are talking about it seriously. That they're not too distant future. This will be sufficiently mature, this technology, to think about, a blind person entering a car and telling the car, take me to work, and it will be able to do it. In hospital as well, and so on. Now, the study or the development of intelligent thinking machines is a collaboration between two major areas of science, brain research on the other hand, and computer science on the other. So these two together are deeply involved and intimately involved in the science of creating intelligent machines. And the interactions go both ways. The brain teaches us about possible ways of what intelligence is and how to build machines, and machines are helping us to understand in new ways, construct theories, and understand in new ways the information processing that is going on in the brain. This collaboration between brain on the one hand and computers on the other has really taken off tremendously. To give you just one example, there is now in Europe, there is a competition for mega grants, for mega projects, two huge projects. Each one will be a scientific grant that will receive €1 billion to run the research program. There has been first round, there are 6 finalists in this competition, and 2 of these finalists, one is a large-scale simulation of the human brain in supercomputers, and the other one is the construction of intelligent robots with human capabilities. One reason or one change in recent years that is one of the driving forces behind this emerging tight cooperation between brain and computers are new abilities to image and see the brain in action. Until recently, the ability to see and investigate, study the human brain has been pretty limited. Most of the brain studies have been conducted on animals where experiments can be done. But with new techniques, we can now image the human brain in action. For example, using this machine, which is called fMRI, functional magnetic resonance imaging. This is a sort of an MRI machine, but the little f in front, this f, stands for the word functional. What it means is that rather than seeing the structure of the brain, you can see the function of the brain, which part of the brain is now active. So I can tell you, inside this machine, think about a particular poem by a poet you like, and you will see which part of the brain this poem sort of exists and activated when you recite this poem to yourself. Through this machine, one can see maps of the entire brain in action, and you can see here what the scientist looking at the machine while the person is in there and performing a task. One can get maps like this, which give you in real time the full activation of the entire brain. And an amazing thing that has been done recently, this is used for for answering many interesting questions, but one in particular which is interesting to see is the ability to reconstruct the human sensory experience from the brain activity. So what we see here is what scientists have done, showing a person an image. In this case, is this French policeman or whatever this image is this. But the experimenter doesn't see this image. The experimenter just sees this map of the human, the subject activity, the subject who is looking at the image. The brain is activated. This is the brain activity. And having read this brain activity, it is now possible to reconstruct what the person was actually seeing. And you can see the quality of the reconstruction. So this is what was reconstructed from the brain activity. Here is another example, and there is a full movie, a person watching movie, and the reconstruction. So this shows how one can now understand and interpret at least some of the brain activity, and it brings in interesting questions. For example, would it be possible with this technique to read out dreams? Because during dreaming, nobody knows from the outside what you're doing, but recording brain activity and performing this kind of reconstruction, maybe we can follow in real time and see what a person is dreaming about or thinking about. So you can see that this is 2 minutes. Okay, so this is the next to last slide, so the time is working well. An area I'll just mention very briefly, but just to show you, it's not something that we have made a lot of progress in, but it's something we are starting with, the scientific community, but showing you sort of the ultimate at what kind of interesting things open up. When we look at the brain, one surprising thing was that how the brain activity is divided between conscious, aware activity and unconscious activity. It turns out that a lot of activity, when you're thinking, looking, and so on, can go on in the brain without you being aware of what's happening. So some brain activity leads to consciousness and awareness. Some other brain activity, for some reason, does not lead to awareness and consciousness. So the whole business of can we look at the brain, distinguish between the states of the brain that lead to conscious awareness, those that not, and get a handle, start to try to understand how these subjective experiences, consciousness and so on, can come out of brain activity, and consider the fact whether intelligent machines of the future, can we expect that they will have some sort of awareness as well. So to sum up, what's next? In the near future, it's clear that intelligent systems will enter our lives more and more. They will have larger and larger influence on our society, on our economy, and so on. And as I said, these advances will come from a tight integration between brain science and computer science. So brain centers or scientific centers that have this collaboration will benefit. In the further future, it's clear that systems will become more and more intelligent, more and more clever, and in many domains will probably be more clever and more intelligent and more capable than humans. we will come to count on them and trust them more than we trust our own judgment, like in the medical diagnosis I mentioned before. It's unclear, but an interesting question, will they ever develop any kind of awareness similar to the kind of awareness that exists in our own brain? And finally, what will be the long-term influence of such a situation on the individual psychology and on society when we live amidst machines which are as intelligent as we are, and in some cases maybe even more? Okay, so thank you very much for your attention.
Your turn now. Question.
I'll be more than glad to take any comment, question. Yeah, at the back there. But just speak up so that people can hear. Okay. She asked, what are the dangers? I think especially when in light of the last slide with all this, living along this highly intelligent machine, or just the slide before that one can look into a human brain and in some sense see what the person is thinking about. It certainly has some scary parts. And I think this is like many scientific discussions. In a way, it goes beyond science. I mean, there are tremendous things. We can increase intelligence, we can help people, we can solve problems, and there is a lot of promise, and people are excited about the great promise. Like in many great inventions and scientific advances, there is danger. Invading privacy, using it for the wrong purposes. And as I also mentioned, even without using it for the wrong purpose, just what it does to the psychology and to society, living this completely new situation. There are dangers, and I think that's one conclusion from this is that it's not just science, but these things should be discussed, and that's one reason why I think for us, as scientists, are really glad to discuss it and bring it out to the open and tell it to the public. It's not just because we are happy to talk about our interesting work, which is certainly a part of it, but I think it's really an important mission, if you want. I think that these issues should be discussed, and this presidential conference is certainly a good place to do at least a little bit of it. Yes.
So on your university research, what is the focus in Israel on what we're doing, and what is the role of the new centers of research excellence in this context?
Right. So the Israeli connection. Israel is really a leader both in the theory and I think in the practice of these things. In Israel, both in Jerusalem, the Hebrew University, at the Weizmann Institute, where I come from, for many years now, they were very early on in this wave of connecting theoretical computer science and brain research. And Israel is considered a leading country among the scientific countries of the world. In fact, Idan may know that better than I do as a person who is involved with the ICNC. It was selected in Europe as the best educational program for students in brain and computation, right? So there are many programs in the world studying, combining brain and computation. There was some evaluation committee, and they selected the Hebrew University one as the best in the best in existence. So Israel is leading, or is certainly in a leading place, along with other larger places, and in the applied applications of this as well. I mentioned, for example, Mobileye, the computer vision company, but it's not the only one. And the centers are very helpful in making this larger, and in particular, bringing back good people, which is a major, major thing. We have some wonderful Israelis out there. If we can bring some of them back, it would be great. And this is part of what these centers are doing. Yeah?
You talked about intelligence. What about wisdom? I think that the one thing that is the most important thing is thinking outside the box and not just reading chess, but rather having some creative thought and things that might be more complicated than just.
I agree, and I think that we are not there yet, but I think that a huge jump between the two big successes that I showed you, sort of the chess and this Jeopardy, and the Jeopardy can really exercise some interesting judgment. It's still not it's still not an automated scientist and so on, but it's really impressive. People, if you ask people in the field, when IBM started working on this project, whether it will manage to win Jeopardy, my bet is 9 out of 10 would tell you no way, that it's too difficult. So even we are surprised that the rate that things are going are progressing. So we'll see. You're completely right that these are the uniquely human and important aspects of the brain, but I see no limitation. Things are getting there.
I'm sorry that we have to. I'm sorry. Shimon will be outside. We can talk maybe later. Sorry.
Right. So thanks again for your.